sample, N2. Schematically, this is a handout. Hopefully this will make it obvious if it's not already obvious. Every one of these rectangles, of which there are 48, is an element of my population. That's my whole population, those 48 units. In regression sampling, regression ratio sampling, I can think about at least knowing the auxiliary variable on every unit. Now it turns out I don't actually have to have that, I just need to know what the mean is, or the total is. But schematically we can think about it as just knowing the auxiliary variable on every unit. So the only sampling I'm doing is selecting some number of units on which I observe Y. Right? That's the only sampling we did in regression ratio estimation. In contrast, same population, but now I don't know the auxiliary variable for every unit. Instead, I take a large sample, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 20 units, 20 of the 48 units, and I observe the auxiliary variable on those units. So N1 is 20 in this illustration. And then on a subset of those units, 1, 2, 3, 4, 5, 6, I also observe the variable of interest.
So your N2 would be 6.
Yes.
And your N would still be 48, capital N.
Yes. So, is that clear? Yeah.
Just quick redo that. In your regression ratio, you find you only sample the units on which you want to find Y.
Yep.
Is that what you said?
Yep.
But on here you have
Some that I just have X,
two N's.
some that I have X and Y.
Yeah. Okay.
Other questions? So the estimators. Again, we will look at the possibility of using a regression estimator or a ratio of means. Remember last time I said we'll temporarily ignore the existence of the mean and ratios estimator. We'll come back to it later, but these will be our two options. Either a regression estimator or a ratio of means estimator. Do those look kind of familiar? There's the pure, so to speak, the regression estimator we looked at before. And there's the ratio of means estimator we looked at before. Don't these new estimators look kind of similar? Well, I see I put a 2 on here, but I didn't need to. The only difference between 6.1 and 12.1 is that I substituted x bar 1 for mu of x, because that's why I'm doing this, right? I don't know mu of x. So which is a better estimate of the population mean of x? X bar 1 or x bar 2? X bar 1 is a bigger sample, right? X bar 2 is just the mean of the sample that I have both x's and y's on.
What does the RD stand for?
Thank you for pointing out. Someone said it?
Regression double?
Yeah, regression double sampling. I think we used a capital R for regression. Here we're adding on to it double sampling. Same in the ratio means, and again it's RMD versus RM. Same in the ratio means, I just substituted x bar 1 for mu of x. Of course. That's why we did this, because we didn't know mu of x. The only thing we did different was try to get a good estimate of mu of x using a larger sample. This is just pointing out that these two things correspond to one another. They're based on the same units, just like x bar and y bar were in the regression context. Any questions on that? So yeah, it's a new approach, right? But it's just a simple extension of what we already talked about. Conceptually, it's a simple extension. And it's one that allows us to apply this technique more broadly, that is regression ratio estimation, more broadly. That's why it's of interest to us. Practical aspects. And I should remind you again, what units will I calculate V1 hat using? What units will I use to calculate V1 hat?
Yeah, no, first, next one, or the where you send them both.
Yeah, the N2 units. Okay. Well, we got estimators. We need standard errors. Our formulas keep putting on weight. Right? And they'll get longer. And I just present them for completeness. There's not a whole lot new here. In fact, there's nothing new. Formula's different. What do I mean it's different? It's different than the regression estimator standard error. Doesn't it have to be? Yeah, because we don't know mu of x. Don't we need to pay a penalty for not knowing mu of x? Yeah. Knowing it is better than not knowing it. Right? So we have to pay a penalty in the sense of our precision won't be as great. Can't be as great.
S squared y-x, is that the standard error about the regression?
Yeah, same thing as it was before. Shows up twice in this equation. Showed up once before. This last thing I said is probably most easily seen in the ratio of means standard error. And again, think about the notation here. S in both cases, so it's got to be a standard deviation or a standard error, but it's subscripted by an estimator, so it must be a standard error. And this is for regression estimation and double sampling. This is for ratio means estimation, double sampling. So if you compare this, and I didn't put the formula up, but if you compare this to the standard error formula for ratio of means estimation, basically it's just that. Of course, there was no N2 and N1. There was an N, small n, and a capital N. But that was the formula, basically. This SR squared is the same as it was in ratio of means. So that must mean this is the penalty we pay for not knowing the mean of x, the true population mean of x. This is the extra error that we incur by not knowing mu of x. So how do we drive that error down? By making n1 bigger. By making n1 bigger. Of course. It's just random sampling. That's a random option. Is that clear? The extra error we incur. Notice that there are sort of two finite population correction factors here. Right? This term comes from the second phase. And the second phase is N2 of N1 units. So the finite population correction factor is
Can you repeat what the small s squared r was in the first term? Nope, the one above.
Yeah, it's this.
Oh, that's just the variance?
It's just I didn't want to have to write that down here.
Oh,
It's this combination. It's just a shorthand notation.
Oh, I see.
Rather
I
than
missed
having to
that.
write all of
Okay.
that here and
Okay.
making this even bigger, I just called it S R
I didn't see
squared.
that in the bottom, so that makes sense, okay.
Yep,
Is your variance over your N1, is that part of your penalty, or is your penalty?
yeah, this whole thing's a penalty.
Okay.
That whole thing's a penalty. Right? Because what I said was, what I've not covered up is essentially the standard error for ratio estimation. I have to add that on if I also double sample. So that's the penalty. The extra error we incur by not knowing mu of x.
So S squared R is just your variance?
No, S squared R is just a label for that quantity. It has no interpretation. It's just a label. That's a good point, right? Because we always want to try to interpret things. But in this case, there is no interpretation. I could have called it Tom. Okay? That's a good question. Other questions? Always got to ask these questions. If I wanted to estimate the total, what I gave you was estimators for the mean per unit. If I wanted to estimate the total, what would I do?
Multiply by n.
Multiply by capital N. Right? Sounds like a broken record. It is a broken record. How about a confidence interval for the population total? How would I get a confidence interval for the population total? Another broken record. How would I get a confidence interval for the population total?
Estimate plus or minus T times your standard error.
Yes, estimate plus or minus t times the standard error. All right? You know how to estimate the total, you know how to estimate the standard error. Estimate plus or minus t times standard error. Question, John?
No, you just answered it.
We need to know degrees of freedom, right? To get our t-statistic, we need to know degrees of freedom. Same as for regression ratio estimation. If we're using a regression estimator, it's N2 minus 2. If we're using a ratio estimator, it's N2 minus 1. Because it's the second phase sample where we get information on Y, correct? So that's where the degrees of freedom arise from.
Can you repeat that?
Sure.
Two?
Regression confidence interval based on the regression estimator. The degrees of freedom will be N2, that's the second phase sample size, right? Minus 2. We lose 2 degrees of freedom, one for having to estimate